As we move into the fourth lesson of this unit, we are now moving into graphing inequalities. So in the previous lesson we were actually graphing the equation of a line. Now that particular lesson is going to be vitally important to your ability to do this lesson, because in the process of graphing inequalities you're actually graphing the line that is part of the inequality. And so if you don't understand how to graph lines in slope-intercept form or standard form, then you'll need to go back and review lesson 3 before you move into this particular lesson. So I'm going to make the assumption that you're ready to go, and we're going to move into graphing linear inequalities. Now, in our first example here, before we even start an example, we have a little concept summary, we have a little step-by-step process, and you can see this little box has a two-step process. What I'm going to do is I'm going to break this out actually into a 4-step process. I'm going to take some of the steps that are kind of combined within that box, and I'm going to break them out into individual steps so that you can see them a little bit more clearly. So as I go through this, I may write down 4 total steps, and that's just to kind of help break it down a little bit into simpler and easier steps to remember. So let's take a look at what we're going to have to do to graph an inequality. In order to graph an inequality, we first need to start by graphing what we call the boundary line of the inequality. Now, what that simply is that's the line of the equation if it were an equal sign. So you can see here in example number 1, and I'm going to take you through part A, and I'm going to let you go through part B on your own before you work a sample. But graphing a boundary line simply means taking that inequality and rewriting it. And when we rewrite the inequality as an equation, we are now going to graph the line y equals to -2. So you can see our first step, and this is where I'm going to start breaking it up into more detailed pieces. We're going to graph line first. Okay, and so once we do that, we then have the start of our graphing an inequality. Now, as we're going through this process of graphing a line, before we just go slap a line down on the page, there's a second part to this. Depending on what the inequality is, if it's less than or greater than, we would give it a dashed line, meaning it's not equal to the values that are on that line. However, if it's less than or equal to or greater than or equal to, we are going to graph a solid line, which is indicating that all of the values on the line are equal to the given inequality. And so we can say that our second step really is determining whether we are working with a dashed or a solid line. So once you decide to graph y equals -2, then we're going to decide whether we need to graph a dashed or solid line. And you can see from sample A, it's a less than sign, but it is not equal to, so we're going to actually graph a dashed line in this particular case. And so we would move on to the next step after the line is graphed. Now, if we recall from a previous lesson, we talked about what a solution was. Well, in a solution for an inequality, it's going to be all of the values or ordered pairs on the graph that actually make the inequality a true statement. Now you can see right now that we're only working in one variable, and I said every ordered pair that makes it a true statement. And so what happens here is we have y is less than -2, so I'm only going to use the y value from the given points. Now, in order to represent that, I need to shade all of those points that are considered solutions to the graph, or solutions being true statements to the inequality. Well, the only way for me to determine which ones of those points, because there's infinitely many, are solutions, I need to test a point. And so our third step in this is going to actually be to do a test point to see where the solutions lie. And so you can see that the most popular test point to try is 0, 0. Now, we're going to take the y value from the 0 point, and we're going to plug it in to the inequality. And so I'm going to say y is less than -2. Now, if we say that 0 is less than -2 by replacing the y with 0, we can see that 0 is not less than -2. So this is actually a false statement. Using a little inductive reasoning that you should recall from geometry, that would tell me that 0, 0 is not a solution to the inequality. We want all of the true statements. And so by using that test point, what we can say is that any point on that side of the line is not a solution. And so you can see here that on this side of the line, where our test point was, all of those are false statements, and so they are not solutions. Now, if I wanted to test a second point, I could say I could test the point 0, -4. 0, 1, 2, 3, 4, -4 would be down here. So I'm going to take the y value from there and say -4 is less than -2. And I can see that that is a true statement. So that means that every portion down here creates a true statement, which means that all of those values below the line would be considered solutions to the inequality. And then that's our fourth step. We want to represent all of the solutions to the inequality by shading them in. And so that is the quickest, easiest way to represent all the solutions, because there's an infinite number of points below that line that are solutions to this particular inequality. Now, you can see in this particular graph the shades of blue were kind of difficult to see on the line. If you recall, since this was not equal to, this should actually be represented with a dashed line, and it's very difficult to see on this graph. And so there you have our first inequality, graphing inequalities. Now, go through those 4 steps that I just broke it down to, follow part B, and you can see in part B we're dealing with the horizontal line as opposed to a vertical line as opposed to a horizontal line. So go ahead and just follow through example part B. Now once you're finished doing that, I'd like you to come down to sample problem number 1. And sample problem number 1 has a part A and a part B, and I would like you to go ahead and pause the video and try to work both of those samples.